Question 11 says divide the LCM of 36, 72 and 144 by their HCF. That means you have to find the LCM, the HCF, and you are going to divide the LCM by the HCF. So let's start with the LCM first. Rule our line. We have our 36 here, rule another line. We have 72 and 144. We're starting with the LCM. You know, when finding the LCM, you divide through by the prime numbers, starting with the lowest prime number. So we know our first prime number is 2, the next is 3, the next is 5, next is 7, 9 is not a prime number, 11 and so on. So let's start with 2. 2 can go in 36, 2 in 36 is 18, 2 can go in 72, that's 36, 2 can go in 144, that's 72. We know 2 can go in at least one of these values, so we use 2 again. 2 in 18, 2 in 18 is 9, 2 in 36 is 18, and 2 in 72 is 36. If you look through, 2 can still go in one of them, 2 can still go in 18, and 2 can still go in 36, so we use 2. We know 2 in 9 cannot go, it comes to the remainder, so we repeat our 9. And like we do in LCM, when you have a remainder, you just leave it like that. Then 2 in 18, 2 in 18 is 9, that's 18 divided by 2. 2 in 36 or 36 divided by 2 is 18. Now 2 can still go in one of them, that's 2 can still go in 18, so we use 2. 2 in 9 comes to the remainder, that's 4 remainder 1, so repeat the 9. 2 in 9 also still comes to the remainder, repeat the 9. Then 2 in 18 is 9. 2 can't go in any of them, so we'll move to the next prime number, which is 3. 3, we say 3 in 9, that's 3. 3 in 9, that's 3. And 3 in the third 9, that's 3. 3 can still go. Write our 3 here. 3 in 3, 1. 3 in 3, 1. And 3 in the last 3, that's 1. So we've gotten to 1, 1, 1. Our LCM is therefore the multiplication of all these prime numbers I can divide through. So we have LCM equals 2 times 2 times 2 times 2. You know, we have 4 2's here and 2 3's here times 3 times the final 3. LCM with our calculator is 2 times 2 times 2 times 2 times 3 times 3 is 144. Now we know the LCM of these three numbers, which are 36, 72 and 144, is 144. Next we have to find the HCF, so we'll come to the other side. Like explained under the foundational series, there's a simpler or an easier method of finding the HCF using a method that looks like finding the LCM. Let's just go over it, and if you have a problem with that, you can just go to the foundational series and scroll down to where you have HCF and look at all the methods available in finding the HCF. So we have 36, we have 72, and we have 144. We have to find the HCF of these three numbers. Now in finding the HCF, similar to the method used in finding the LCM, here we also still apply the prime numbers. But in this case, the prime number would have to be a number that can divide all through the three numbers, or as many numbers as you are given without a remainder. 2 can go in 3 of them, so we'll just start with 2. 2 in 36 is 18. 2 in 72 is 36. 2 in 144 is 72. 2 can still go in 3 of them, use 2 again. 2 in 18 is 9. 2 in 36 is 18. And 2 in 72 is 36. Now we see that 2 can go in 9, so we can't use 2. Although 2 can go in 18 and 2 can go in 36, we can't use 2. We'll move to the next prime number, which is 3. We know 3 can go in 9, 3 can go in 18, and 3 can go in 36. So we go with 3. 3 in 9, that's 3. 3 in 18, 3 in 18 is 6. 3 in 36 is 12. We'll try 3 again. 3 can still go in 3 of them, so we use 3. 3 in 3, 1. 3 in 6, or 6 divided by 3, 2. 3 in 12, or 12 divided by 3 is 4. We can see 3 can go in all of these numbers. The next prime number is 5. It can't go because all of them are less than 5, so this is where we stop. So our HCF is 2 times 2 times 3 times 3. We see that the prime numbers that can go through these three numbers are 2, 2, 3, 3. So we multiply them all together. Our HCF is therefore 36. Now we know the LCM is 144 and the HCF is 36. So it says divide the LCM by the HCF. So it's LCM divided by the HCF. We know our LCM is 144 from our calculation and our HCF is 36. 144 divided by 36 equals 4. Our answer is therefore 4. The answer from the options is B. That's 4.